about something you use every day in your life. Do you know what that is? Well, it's electricity and circuits. We know electricity from a prehistoric time. Our ancestors know electricity from static shocks and thunder. The first one to coin a name for electricity is scientist William Gilbert. He used electricus, a Latin word, to coin electricity. So, what is really electricity? To answer that question, we need to learn about atoms. So check out my periodic table video. So, electricity is the flow of negatively charged electrons. There are several sources for electricity, such as a battery, a solar panel, and a wind turbine. So there are two types of electricity. One, AC, which stands for alternating current, and the other, DC, which stands for direct current. First, let's look at DC. DC means direct current, which means direct. So the polarity never changes, which means the positive end of the circuit, positive end stays positive, the negative end stays negative. On the other hand, AC, the polarity keeps changing. So in the first half, one end will be positive and another end will be negative. But in the other half, it'll change. To explain that more clearly, I have made this model. So this is A as shown, and this is B. So A is negative because it emits electrons, and B is positive because it collects electrons. So when I do this, it's the first half of the cycle. And when you do the second half, B turns into negative and A turns into positive because now B emits the electrons and A collects the electrons. So then if I do that, then it's the second half. And why is this line here? Because that means there's no current. But then we use electricity in our home. Then why does the lamp switch off and on? Because it does it so fast we can't even see it. There are three important things we should learn about electricity. Number one, voltage. Voltage is a pressure which pushes the electrons. For example, we have a tank full of water. There's a type here. When you open the tank, the water rushes super fast because of the pressure. The voltage is created by a potential difference. Voltage is represented by a capital V. Voltage is measured in volts. Number two, resistance. Resistance slows down the flow of electron. For example, your car is the electron, and this is the resistance is a speed breaker. So when your car goes so fast, it helps you slow down. So resistance is measured in ohms. Resistance is represented by a capital R. Next, current. Current is how much electrons flow in a period of time. So current is measured in amps. Current is represented with a capital I. Holmes was a scientist who derived the relationship between voltage, resistance, and current. According to Holmes, he said voltage equals current into resistance. You can use this triangle to find the voltage, resistance, and current. For example, if you want to find the current, you can do voltage divided by resistance. If you want to find the resistance, you can do voltage divided by current. Now let's go on to two types of circuits, series circuits and parallel circuits. First, let's look at series circuits. In a series circuit, one's output will be the other's input. So what I mean by that is this component's output will be the input for this component. In series circuits is used in Christmas lights. In a series circuit, if you take one component off, it'll be like the whole circuit is an open circuit. This is a parallel circuit. In a parallel circuit, each component has its own path. So R1 has its own path, R2 has its own path, R3 has its own path. If I take one of these out, the others will still be glowing. Parallel circuits is used in our houses. So if you switch off the light, you can still watch the television. If your home's appliances were connected in series, you should have on everything so you can use one thing. So now let's use Ohm's law to find the resistance, current, and voltage in the series circuit and parallel circuit. First, let's look at the series circuit. In the series circuit, the current remains same because there's only one loop for it to go. And the voltage decreases because the resistance adds up. So the total resistance will increase because in a series circuit, the resistance adds up. So the total resistance will equal R1 plus R2. Now let's go on to the parallel circuit. In a parallel circuit, the current increases because in this there's only one loop, but in this there's more than one loop. So all of them will be added up in this part. So the current will increase. The resistance will decrease because in a parallel circuit, the resistance divides up, and the voltage remains same. For example, if there's one electron here, here, and here, first voltage will push this and push that and push this. So the pushing force will be the same. Thank you for watching. If you have any questions or comments, comment below. Nandri Vanakkam.